Okay, so continuing on with chapter 5 material, we're gonna move on to a new topic here, but still a little bit related. So this number one, we have 80 male participants between 19 and 24 who measured between 68 and 70 inches tall, were weighed, and their weights were recorded in kilograms. The mean weight was 82.36. Research shows the maximum healthy weight for this range of heights is 74 kilograms. How are the shape, center, and spread affected when 74 is subtracted from all of the data values? So we can basically see what's going on here with the two histograms here. So here's the original data. Here's the data after we subtract all the data, all the 74 from all the data points. And if we look at the shape, obviously the shape is exactly the same. If we took away the numbers along here, we would not be able to tell the difference. And if we look at the box plots are exactly the same. So shape is unaffected. What about the center? So the center, and you kind of, I mean, we don't have to worry about the precise center, but if you look at the range of data, 50 to 150, 100 would be in the center of that. Even it's not really the center of the histogram. We could call this the center of the histogram. Whereas over here, negative 24 to 76, that's still the same range. That's still a range of 100. And now 26 is in the center. So the center has definitely shifted, and not coincidentally, it shifted by 74. And then if we talk about the spread, again, we can look at the range from 50 to 150. And I'm just kind of going with what the marks are on the y-axis. Obviously, we have data point way up here, but 50 to 150, we can kind of use that as a guide, negative 24 to 76. So the spread is the same. So the center shifts by 74. Shape and spread are unaffected. So the adding or the subtracting does not affect the shape and the spread, but it does affect the center. And the example I'll use in class is, imagine you took your first test and you got an 80 and your friend got a 75. So the difference between your grades is 5 points. And then let's just say I've decided to add 10 points to everyone's score. So now your score is 90 and your friend's score is 85. So your scores moved, and the class average would, if I did it to everyone, the class average would go from whatever it was to 10 points higher. But the difference between your score and your friend's score is still the same. So and same to everyone else, relative to everyone else, you were still in the same spot. So the spread is not affected, the shape is not affected, the center is affected when you're adding. All right, so if the same number is added or subtracted or added to all the data values, then measures of spread. Now, what are the measures of spread? That might be a good thing to make sure you know. We were talking about IQR, we were talking about standard deviation, and we were talking about range. These are not affected. That says range right there. These are unaffected. And then the measures of position or measures of center. So this would be mean, mode. We could say Q1, Q3, any data points, any of those. Median, we could add in there. Shift by C, whatever the constant is, whatever you're adding or subtracting, that's how those are going to shift. So all the data points are going to shift. Q1 and Q3 are also, I point that out because IQR is not changing, but these two are, they're just changing by the same amount. So the difference between those two is not going to change. So, all right, what if we multiply? What if we multiply? So let's say we multiply all the data values by the same number. So we're going to convert from kilograms to pounds. I think that multiplies by about 2.2. So what happens to the position of spread? So in this case, the center, and we'll just say the mode is the center, is about 80. Here the mode is about 160, a little bit above 160 maybe. So that's changed. The spread here was, that's I guess about 60 up to 160. Here we have 120 all the way up to 320. So the spread has, we've gotten more spread out by multiplying. So in this case, all measures will change. So, and be multiplied or divided, whatever that, so if it's 2.2, I think that's what it is. The mean will be multiplied by 2.2. The median will be multiplied by 2.2. The standard deviation will be multiplied by 2.2. Everything is multiplied by 2.2 when you multiply all the data points by some number. All right, so let's look at this example. We have the mean and standard deviation in the men's combined event at the Olympics were 168.93 seconds and 2.90 seconds, respectively. If the times were measured in minutes, what will be the new mean and standard deviation? All right, so if we go from seconds to minutes, are we going to be multiplying or dividing, or are we going to be adding or subtracting? So obviously we're going to be dividing. To go from seconds to minutes, you're going to divide by 60. So both of these are going to change when we divide. So the new mean will be 168.93 over 60, and that is 2.816. And then the new standard deviation will be 2.90 over 60, and that is 0.048. And now these are both measured in minutes. And so that's how you do that. Now, if we just deducted 10 seconds or whatever it was, then we would subtract 10 from that. We would not subtract 10 from that. If it's adding and subtracting, those would not be affected. So keep that in mind. Now, you may have a question on the homework or quiz where it's kind of doing two things at once, like you're multiplying everything by a constant and then you're adding. And in that case, they're both going to change the mean or the median or the mode, but then only the multiplying will affect the standard deviation. So just keep that in mind when you're working the problems. If you have any questions, you can feel free to email.